Okay, this question says the following diagram shows a circle with centre O and radius 40 centimetres. Our diagram here, it says the points A, B and C are on the circumference of the circle and AOC is 1.9 radians. So this A, B and C are all on the circumference, and this angle it's talking about here is this angle here, which is marked as 1.9 radians. So then A says find the length of the arc ABC, so it wants to find the length of this part around here. So we should know that arc length is equal to r theta when theta is in radians. So all we need to do is put in the radius, which is 40, and then multiply that by 1.9 radians, get your calculator out and just do 40 times 1.9, which gives 76 centimetres. Okay, part B says find the perimeter of the sector OABC. So it means from here, round here, and around here. So we've already worked out the length of this part, and then we just need to add OA and OC, which are both 40. So this is going to equal 76 plus 40 plus 40 again. So that's going to equal 156 centimetres. Alright, finally it says find the area of the sector OABC. So it wants to know the area of this part here. I'm just going to shade that in. So it wants to know the area of this section here. So again we should know the equation for this. So the equation for the area of the sector is equal to 1/2 r squared theta, again where theta is in radians. So it's going to equal 1/2 times 40 squared times 1.9. So we get the calculator out. So it's going to be 40 squared times 1.9 and then divided by 2. So it's going to be 1,520 centimetres squared. Okay, this question says the maximum temperature T in degrees Celsius in a park of 6 randomly selected days shown in the following table. The table shows the number of visitors n to the park on each of those 6 days. So you'll see here we've got our maximum temperature, and then we've got some numbers, and then we've got the number of visitors, and we've got some more data here. And it says the relationship between the variables can be modelled by the regression equation n is equal to at plus b. So if you compare this to y is equal to mx plus c, we can see that this is basically the same form as this. So we should have a straight line graph here. If we plot n on the y-axis, number of visitors here on the y-axis, and then the temperature here on the x-axis, we should get a straight line graph, and the gradient m would be equal to this value a it wants us to find, and then the y-intercept c would be equal to this value b. So we need to find the value of A and B, which we can do by making a graph with your graphical calculator, inputting the data, plotting the graph, and then finding the value of M and C. So what I've done here is to produce this on a spreadsheet. So I've got the data here. Here's the data I've input. So this is T values here, and this is N values here. And I've plotted it with the number of visitors on the y-axis and the temperature on the x-axis as specified. You can see the points here on the graph, and then there's a line of best fit which has been plotted through, and the equation for the line is 0.667x and plus 22.2. So that's the value of A, and then that's the value of B. So A is equal to 0.667 and B is equal to 22.2, just taking those values from the graph. Alright, so you do that on your graphical calculator and get the same values that I've got there. Next it says write down the value of R. So R is a measure of how well the line fits the data. So if I look here, you can see my points are a little bit scattered, and these two over here aren't all that close to the data, to the line. So my value of R, or on my spreadsheet here it's given me R squared, which is 0.852, is a measure of how well the line fits the data. So the closer that is to 1, the better the fit is, and the further away from 1 is, the worse the fit is. So you can see it's not too bad. So what I need to do here, because I've got r squared, is to work out r. I would just have to do 0.852 and then take the square root, which has given me 0.923. So r is equal to 0.923. Again, you'd get that from your calculator by doing it similar to what I've done with the spreadsheet. Part B. So part C says use the regression equation to estimate the number of visitors on a day when the maximum temperature is 15 degrees C. So because we've got the information for the equation now, all I need to do is substitute the values in, including 15, to work out what n is. So n is going to equal A, which is 0.667, multiplied by the temperature, which is 15, and then plus B, which is 22.2. So I can take my calculator, stick those values in, so I can get 0.667 multiplied by 15, and then add 22.2, which gives me 32.205. Obviously I can't have 0.205 of a visitor, so I'd have to round this to the nearest integer, which would be 32. So I would expect 32 visitors on a day when the maximum temperature is 15 degrees C. Okay, this question says the following diagram shows the graph of a function y equals f of x for between -6 and -2. So here it says the points -6, 6, -2, 6 lie on the graph of f. So -6, 6 is here, -2, 6 is here, and it says there's a minimum point of -4, 0, which is here. So first part says write down the range of f. So the range is what we get out. So range is the output, or the y values. So we can see here, if we just look at the graph, we can see that y varies between 0 and 6. So we would just need to write 0 less than or equal to y less than or equal to 6, because values up to 0 are allowed and up to 6 are allowed, because it tells us here 6 and 0. So we definitely need to have less than or equal to, less than or equal to here. Alright, next part of the question says let g of x equal f of x minus 5, and then on the grid above sketch the graph of g. So we can see here that g is just going to be a translation of f. Since the translation takes place, or the minus 5 is inside the brackets, we've got to do x minus 5. So what we'd have to do is take a value of x and then subtract 5 to get back to where we were. So what this is going to do then is give us a translation of 5 units to the right. Units to the right. Alright, because if we took a value that was 5 greater, so if I take the value here 1, first thing I would do would be subtract 5 here, and then I would run it through the function, so I'd get the same as we had before. So all I need to do then is just draw this graph exactly the same as it was here, except shifted over 5 to the right. So instead of starting at -6, it's going to start at -1. And it's going to go down instead of 4 to 1, like so, and then instead of going to -2, it's going to go to 3, like that. So that is going to be g of x, like so. Okay, finally it says write down the domain of g. So the domain is the input, or x. So again, if we look here, we can see that x permitted values are from -1 up until 3, because that's what we've got information for. So I would just need to write x is greater than or equal to -1 and less than or equal to 3.